Want to give your writing a voice? Discover how easy it is to do using OpenAI's text-to-speech service and Java. Welcome to Tales from the Jar Side. Welcome. My name's Ken Cousin. This is part of a series of videos on using the OpenAI APIs from Java. This one is particularly simple, as it turns out, although there are some quirks to it, so let me save you the trouble on those quirks, and then you'll be able to use this right away. What we have here is the documentation for the OpenAI API, specifically the section on text-to-speech. And you can see that what they do is they provide an endpoint. Let me make this a little bit bigger. So there's a speech-based endpoint for their text-to-speech model. There are 6 built-in voices. You can't add your own, you can't customize them in any way, but it's easy enough to use. Now they have examples here, and let me scroll down a bit. I'll show you the quick start, and then I'll show you a couple of the samples, and then we'll just go use it, because again, this is among the simplest things that they provide. Let's take a look at the quick start. What they're showing here in the curl model is an endpoint that you'll need to access with a post request. Now, you need to provide your authorization key as usual. We've talked about that several times in other videos in this series. You also need to specify that you are submitting JSON data as part of the body. The actual body you submit, however, is incredibly simple. What you see here is there's a model, an input, and a voice, and that's it. And what you get back is the MP3 file immediately. See, the -- output goes to speech.mp3. Now we're going to have to translate this to something we can use, but this is really simple. Now, there are 2 models available for audio quality. There's a TTS1 model, and then there's a TTS1 HD model. Presumably high definition. But I gotta say, you're not going to hear a dramatic difference between the two. We'll look at the prices later, but you can use whichever one you like, and neither one of them is terribly expensive. And we'll take a look. Now, they do have some demonstrations of their 6 models here: Alloy, Echo, Fable, Onyx, Nova, and Shimmer, and you can play through them and listen to whichever one you like. And go ahead and go with that. Now, the default output format is MP3, and that's what I'm going to use. They do support Opus, AAC, and FLAC if you're interested in that. I didn't experiment with those, but they are not difficult to generate. Easy enough to do it. And they also point out that it's compatible with their Whisper model, so if you give it text in different languages, it can, in fact, provide audio for those languages. Now, let's take a look at the actual API reference. So the first thing is that they show us you do have to supply a post request to the audio/speech URL. Okay, we know the endpoint. Now, as part of the request body, there are 5 apparently, 5 possible options, only 3 of which are actually required. The model we've already talked about, TTS1 or TTS1 HD. The input is the string you wanted to generate audio for. Now, voice is one of those choices we just went through, from Alloy to Shimmer. And then the last 2 are response format, to say which type you want back. Again, if you don't supply one, you get MP3. And the final one is speed, which is basically a double that has a value between 0.25 up to 4.0. And the default is 1. So you can get a much faster reading than you would expect, or slower, depending on how you want to do it. And what it returns is the MP3 file. In fact, it tells you almost nothing. It just says the audio file content is what comes back. Let's take a look at the Java implementation. Now, as usual, when I'm going to access a RESTful web service, I start by focusing on the input and output JSON types and model those as Java records. Now, in this particular case, there's only one input type and there's no output type. So again, this is going to be pretty straightforward. Now I decided to make it a little bit more interesting by putting in some validation as well. Now I am putting in a request called a TTS request, text to service request. And there's our string for model and for the input text that you're supplying. Again, the names of the properties here in the record match the properties in the JSON data. Now for voice and response format, in order to do a little bit of validation with it, I decided to create enums out of that. So here is the enum for voice, and you can see that I use the normal Java convention of using uppercase for constants like this, but in order to make the translation, the serialization from the enum into the JSON data work properly, I added JSON's serialized name annotation to each of them to put in the lowercase value. That way it's obvious even to the most casual observer exactly what's going to happen with each of them. I also, just for fun, added a getRandomVoice method so that I don't have to select a voice each time. I can have some of them come at random just for fun. The response format, again, is just a simple enum with the values MP3, Opus, AAC, and FLAC. So there's some validation. I can only select the ones that are available inside the two enums. Now for the model, for input validation, I put in this sort of constructor inside the braces that doesn't have parentheses on it at all. That's something a lot of Java developers don't realize is available. And really the only purpose of a constructor like that is to do input validation and make sure you get reasonable values for your inputs. So for the string model, I said, let's go ahead and validate it. And I have a simple private method down at the bottom that says if the model is either TTS1 or TTS1 HD, and I put those as constants in the class we're about to look at, then it's valid, otherwise it's not. For the speed, I put in the private validation method that just says the speed has to be between 0.25 and 4.0 inclusive. So in each case, I check that those methods return valid, return true, Boolean, and then go on. Now, I also am providing a constructor here that only takes 3 of those fields, the 3 required ones, and we'll go ahead and supply the response format MP3 and the speed of 1.0 for the other 2 fields by default. So that's it. That's the entire input record. Nothing more to it. It's a simple record and a couple of enums, and we're ready to go. Moving to the actual text-to-speech class, I have a logger in here, so I'm ready to write out different parts of this just to make sure everything's working properly. I specify my endpoint, and I have my attribute to retrieve the key as an environment variable. And here are the constants representing the 2 models that are available. I am going to use JSON, but I don't need to get fancy about it this time. I could have just instantiated the JSON class, but I decided to set the pretty printing because it makes some of the logging a little bit easier to follow. Because there is something interesting I want to show you out of that. I also am going to use the built-in HTTP client that comes with Java starting in version 11. So I simply instantiate that, and as the method says, that will return a new HTTP client with all the default settings. And that's a GET request and prefers HTTP2 and redirection of never and default proxy, default SSL context. We're good. Okay, so this is the basic method that I'm going to want to invoke without any pre or post processing. A little bit of post processing. So what I do is I supply a TTS request, which I'll show you how to instantiate later. Once I have that request, I'll use Google's JSON to serialize that into a string, and then I'll log it because I want to show you what that looks like once you serialize it. To create the HTTP request, I set the proper URL, and I put in my 2 headers here, the OpenAI API key, of course, and the content type, meaning I'm transmitting JSON data. Now, conspicuous by its absence, this is something I want to talk to you about a bit more shortly, is I don't have the accept header in there. Now, some RESTful web services will not operate properly without an accept header that says what type of response you want back. In this particular service, it only returns one type of response, and I'm going to show you that response by logging the headers that come back in the response when we get there. In the meantime, I am going to make a post request and take our post body and just plug it into the body there. So there's my request. Now I will invoke send to do a synchronous request in this particular case, which is very fast as a matter of fact. And this is using the interesting part. For my body handler, I'm using the method of byte array, which returns a body handler of type byte array that will allow me to get the bytes out of it and save this as an MP3 file. So when the HTTP response object is returned, the body has been completely written to a byte array. So my response is an HTTP response of type byte array, and when I extract the body, I've got the bytes. Now I could just return that, but in order to print out some information about it, first of all, I have a method that I added to my regular file utils class that's just going to save that into a file, and I'll show you that later a little bit. I'm also going to log that, hey, I just saved that file into a generated file name. I made a file name that has a timestamp corresponding to when this file is being saved, just so I don't overwrite all my existing files. Also, from the response, I'm going to retrieve the headers. My map method will turn that into a regular old Java map, and for each one, I'll print out the key and the value just so we can see what we get back, and return the body, and the rest of this is just exception handling. In my test, I instantiate that text-to-speech class, and this is the sample that they have in the documentation. You just create a request. I'm going to use the regular TTS1. I'll put in the message, the quick brown fox jumped over the lazy dog. That's what they had in there. And I'll use the first of those voices, the alloy one, and go ahead and generate this. And let's take a look at what we get out of that. Now, the first thing I want to show you is the log of the serialized JSON data. So there's the model, the TTS1, there's the input text, there's the voice, and again, I'm using MP3 and the speed of 1.0 for the output. This is the generated file, which I'll play for you in a moment. In fact, why don't I do that now?
The quick brown fox jumped over the lazy dog.
And that's all there is to it. See how quickly it ran. I got back the response remarkably fast. It took approximately 1.5 seconds. And a lot of that was just starting up Java. This would be a nice application to use the Graal virtual machine on and turn this into native code that I could deploy as a function as a service, because it's basically completely stateless. I'm just sending in the text and other parameters and getting back an audio file. One thing I want to show you are in the header list, what they included was the content type here. Now the content type coming back is audio/MPEG. And that's interesting because normally I would have had to state that, specify that in the accept header in the transmission. But here I didn't have to, and I get back audio MPEG. There's nothing else out of this that it's all that interesting. Let's take a look at running something a little faster. So here's the same voice as the one above, but this time it'll play at twice the speed. Let's take a look at that. And again, everything got generated in a little over a second.
The quick brown fox jumped over the lazy dog.
I don't know. Double speed sounds kind of ridiculous. I'm not sure why you'd want to use that. And it goes up to 4. So I don't know. I mean, interesting to try out just to see what it would look like. Now, here's the thing. You see, it's kind of a pain to get back the MP3 and then have to open it up with a separate application. What I'd really like to do is to be able to have my Java application be able to play that for me. Now, I have to admit this time, this took me longer than I expected. I tried digging into Java FX. I tried to use the media player. I tried to use audio clip. I was able to do it if I waited for it. If I set a thread.sleep long enough that I could let the clip run and then have a test end at the end of that. But trying to automate that process, even using things like a countdown latch, stuff like that, never quite worked for me. So I had a lot of trouble getting that to work. And then I saw a web page that recommended a library to do it for me. This is an old library. This is called JLayer. Now, they do have a latest version that came out like October 3rd of 2022. But the truth is this thing has barely changed in 12 years. I mean, they even say as part of Java Zoom from 1999 to 2008. It's getting to be quite a while ago. So I wasn't 100% sure this was going to work properly, but I'm going to show you it worked like a charm. So they talk about the library a little bit, and what they've done is they've uploaded it as part of a Jetpack dependency. And they even have built-in libraries and everything. Now I could get into this, but let me just show you how simple it is to use in practice. What you see here is the single dependency I had to add in my Gradle build file. The coordinates are com.github.umjammer, and then here's the colon, and there's JLayer, and I'm using the current version 1.0.2. Now that's not in Maven Central, so I had to go in my repositories and add that jetpack.io URL in order to find it. But that's it. Once I did that, now it's part of my project, and let me show you what I can do now. This method right here uses the player class from JLayer, javazoom.jl.player. The player class implements a simple player for playback of an MPEG audio stream. The audio device should not be opened until the first MPEG audio frame has been decoded. Whatever, I don't have to worry about it. All I have to do is instantiate it, and you can see the constructor takes an input stream. So I have this simple method that will allow me to take a file name and plug it in, and I have it saved in my source main resources folder under an audio folder underneath that. So I plug in the file name, I load it as a stream, I wrap it in a buffered output stream, put it in the player and call play, and I'm done. All I need to do is to catch the Java layer exception, and that works. Let me show you how simple that is to run as well. So this test is simply going to play that MP3 given that I already have this file in that audio directory.
The YouTube channel, Tales from the Jar Side, is your best source for learning about Java, Spring, and other open source technologies, especially when combined with AI tools. The companion newsletter, Tales from the Jar Side, is also a lot of fun.
So what I've done is I've renamed that to TFTJS, Tales from the Jar Side, MP3, and now I'm going to play it.
The YouTube channel, Tales from the Jar Side, is your best source for learning about Java, Spring, and other open source technologies, especially when combined with AI tools. The companion newsletter is also a lot of fun.
I sure hope so. At any rate, that's the idea. So you see that works just fine. Not a problem at all. Just creating a player, instantiate the player with the input stream, call play, and you're finished. Now, I also added in a method just for convenience that actually creates the MP3 and saves it and plays it so that I combine them all. So this create and play takes that text and a voice, and I'm using the high definition model, did the text with the replace all and trim and plug in the voice, generate the byte collection, which, by the way, that method will also save it in a file, and then go ahead and wrap it in a buffered input stream and play it all together in one operation. So down here, my thought behind this silliness, this particular bit of silliness, is that I am basically making words for a robot to say. So it feels vaguely like Cyrano de Bergerac supplying words to young Christian who is awkward around the lovely Roxanne. So yeah, it's a reach, but what the heck. So this is a quote from the novel Cyrano de Bergerac, or from the play, pardon me. So let me execute this with a random voice.
A large nose is the mark of a witty, courteous, affable, generous, and liberal man.
And there you go. And if you're wondering which voice that was, again, I have it in the logger. So that was the Shimmer voice in this particular case. And there you have it. That's really all it took. Now, the next step beyond this is I'm going to demonstrate how to do this in a Spring application, because the Spring part will take care of all the networking for me. And all I need to do is to use the HTTP Exchange interfaces. So if you're interested in that, that video is coming. And before I provide that, you might want to take a look at the video that's linked right now that discusses all the details of the HTTP Exchange interfaces, get, post, put, delete, the whole works in a somewhat entertaining manner. I hope, at least I hope so.
Tech dose that never ends.